All right, let's get started. Mr. Trutna here. This is Unit 5. This is the test review worksheet. And this worksheet is going to go quite a ways in helping you understand what you learned and what you need to know for the upcoming test on Unit 5. Okay, so we're going to start with number 1 right here. It says the sum of the interior angles of an octagon is equal to what? And then the second part is we want to find the sum of the exterior angles. Okay, so we are talking about an octagon, so that means this shape has 8 sides. And to find the sum of the interior angles, what you're going to do is you're going to use the formula n minus 2 times 180 degrees. Okay, so this is the formula we're going to use. N minus 2. Then we're going to multiply it by 180 degrees. N is going to be 8 because an octagon has 8 sides. So we're going to go 8 minus 2. Then we're going to multiply that by 180 degrees. And when you multiply that out, that would be 6 times 180. So this is 1,080 degrees. Okay, so that's what the sum of the interior angles is going to be. Then the second part wants to know what is the sum of the exterior angles. Now, to find the sum of the exterior angles, there's no formula. There's really nothing you need to do. There's no mathematical work. The answer is 360 degrees. So no matter how many sides a shape has, this one has 8, the sum of the exterior angles will always equal 360 degrees. Okay, moving on to number 2, same question. We're going to find the sum of the interior angles of a decagon. We want to know what that is equal to. So the first part is we're finding the sum of the interior angles. And then the second part is we want to know what is the sum of the exterior angles going to be. Okay, so once again, to find the sum of the interior angles, you use the formula n minus 2. Then you multiply it by 180 degrees. N stands for how many sides. A decagon means that we have 10 sides to the shape. So to find the sum of the interior angles, you would go 10 minus 2, which is 8. You would multiply that by 180 degrees, and whatever that equals, which is 1,440 degrees, that's going to be the sum of the interior angles. To find the sum of the exterior angles, once again, you don't have to find anything. It's just an answer. It's 360 degrees. Okay, number 3. A regular polygon has an interior angle with a measure of 140 degrees. How many sides does the polygon have? All right, so in this problem, we are trying to figure out how many sides the polygon has. All right, so the formula to find out the number of sides of any polygon is, what you do is you take 360, which represents degrees, and then you divide that by 1 exterior angle measure. Okay, so 1 exterior angle measure. So that means you have to know an exterior angle measure in order to figure out how many sides a shape has. And notice in this problem it says an interior angle has a measure of 140 degrees. Okay, so we would go 360 to figure out how many sides, then we would divide it by, now we're not going to divide it by 140, we're going to divide it by how much an exterior angle is. Alright, so remember the rule is an exterior angle is going to be supplementary with an interior angle, so that means an exterior angle has to be 40 degrees if an interior is 140. Because an exterior and an interior have to make 180. They're supplementary. I would go 360 divided by 40, and that would tell me that this is a 9-sided shape. Okay, number 4, a regular polygon has an interior angle with a measure of 156 degrees. How many sides does the polygon have? So once again, in this problem, we are trying to figure out we're going to find out how many sides the polygon has, and we are told that an interior angle has a measure of 156. All right, so to find the number of sides of a polygon, the formula that you use is you take 360 and then you have to divide it by an exterior angle. Now, Once again, we're doing the same thing that we did in the previous problem pretty much. So if an interior angle is 156, an exterior angle is going to have to be 180 minus 156, which is 24 degrees. So that means we would take 360 and we would divide it by 24. And whatever that equals, that's how many sides the shape has, and that would be equal to 15 sides. So number 4, we are talking about a 15-sided shape. Okay? All right, so then we're going to skip 5, 6, 7, and 8, and we're going to go and we're going to pick it back up at number 9. All right, so in number 9, we're given a polygon here, and it wants to know what is the value of x. And if you notice, x is an exterior angle. So this angle out here is x, okay? So what we need to do to find this problem is that we first need to figure out how much this interior angle is, and I'll call that I because that's an interior angle. And then once we know the interior angle, remember an interior angle and an exterior angle have to be supplementary, okay? So to find the value of I, what I'm going to do is, the first part is I'm going to use the formula n minus 2 times 180 degrees, where n in this case is going to be how many sides this shape has, which is 1, 2, 3, 4, 5, 6. This is a 6-sided shape. So 6 minus 2 is 4. 4 times 180 is 720. Okay, and what that means is that all of these 6 angles, including the I angle, is going to add up to 720 degrees. Okay, so I'm going to find the interior angle. So I'm going to take 100. I'm going to add it to 100. I'm going to add it to 140. I'm going to add it to another 100. I'm going to add it to the I angle, the interior angle, and I'm going to add it to 140. And all of those angles have to be equal to 720. Okay, adding up all these numbers together here, just combining like terms, that would give me 580. So 580 plus the interior angle would be equal to 720. You take away 580 from both sides, that means the interior angle is going to be 140 degrees. All right, so this angle right here is 140, which makes x supplementary with it, because remember, an interior angle and an exterior angle are supplementary. So the way that you would find x is you would go 180, take away the 140, the interior angle, so x is going to be 40 degrees in number 9. Okay, number 10, we're going to do the same exact concept as number 9. Okay, we're going to first find this interior angle here, which I'll call I again, and then we're going to use that and the fact that an interior angle and an exterior angle, and x is an exterior angle, are supplementary. Okay, so we're going to do the same idea. So this is a 1, 2, 3, 4, 5, 6-sided shape again. Okay, so we're going to use the formula n minus 2 times 180 degrees. In this particular problem, n is 6 again, so we're going to go 6 minus 2, which is 4. We're going to multiply that by 180, so that's 720 degrees. And then we're going to use the fact that all of those angles, including the I angle, so the 99 plus the 140 plus the 125 plus the 96 plus the 130 plus the I angle, those will all add up to 720 degrees, and we're going to work this out and we're going to find out what I is equal to. Okay, so as I'm talking to you, I'm just doing it in my head, and you would get I is equal to 130 degrees. Okay, so that's not your answer here. That's going to be your interior angle, which is 130 degrees. And so to find x, we know an interior angle and an exterior angle are supplementary. So we would subtract 130 from 180. So we would get x is equal to 50 degrees. Okay, so that would be number 10. All right, the next problem, we're going to skip all the way over to number 16. And number 16 says, find the value of x and y in the rectangle. Okay, so this is a rectangle right here. We're told this shape is a rectangle. So what do we know about a rectangle? Well, one of the things we know about a rectangle is that all the angles are 90 degrees. Okay, so every single one of the 4 angles in a rectangle are 90 degrees. Now, please do not make the mistake of saying that x is 45 because it's half of 90. Okay, that is not true. The diagonals in a rectangle do not bisect the opposite angles. So you can't say 45 for x, you can't say 45 for y. Don't make that mistake. That's because this is a rectangle. Okay, but what else do we know about a rectangle? Well, remember in a rectangle, if I put a point right where the diagonals intersect, and that point has to be a midpoint between all the corners of the rectangle to that point. So that means that all of these parts of the diagonals have to be equal to one another. Okay, and that's going to be very helpful because that's going to help me find the value of x. And what I'm going to do is, if you notice, this triangle right here that I just highlighted in yellow, that triangle is an isosceles triangle because those 2 sides are equal. Which means that the 2 equal sides are called the legs. The non-equal side is called the base, so this side right here is the base, and then the base angles are equal. So that means that angle and that angle are going to be the same measurement. So then I'm going to use that fact to find the value of x. So what I'm going to do is I'm going to take 72 away from 180. That gives me 108. So that means that these 2 angles, which are equal to each other, have to make 108. So then to find x, I'm just going to go 108 divided by 2. So x is equal to 54 in number 16. Okay, so now I'm going to put a 54 right there. And I'm going to put a 54 over here because they're the same. And then the next thing that you would hopefully notice is that this triangle over here, which I'm also highlighted in yellow, is the exact same triangle as the triangle over here. So what does that mean? Well, it means that everything's the same. So the angles have to be the same. So that angle has to be 72, and these 2 angles have to be 54. Okay, and I'm going to use that now to find y, because if you notice, y plus 54 has to add up to 90 because the shape is a rectangle. So I would subtract 54 from both sides of the equation, and that's how y turned out to be 36 degrees. Okay, so there we go. That would be number 16. X is 54, y is 36. Moving over to number 17. The directions say find the measure of the numbered angles in each special parallelogram. And if you notice in number 17, it's got 4 equal sides, but it doesn't have the 90-degree angles. So number 17 is a rhombus. Okay, and we're going to find the measure of angle 1, angle 2, and angle 3 in number 17. Okay, angle 1, angle 2, and angle 3. Okay, so remember, so now we need to remember the rules or the properties about a rhombus. So the diagonals, right where the diagonals intersect, are perpendicular. So that means in a rhombus, all 4 of these angles in the middle are all 90 degrees. So that means angle 3 is going to be 90 degrees. Okay? Then, the next thing we remember, you hopefully remember about a rhombus is, the diagonals bisect this angle, both of those angles. So that means if that angle is 32, it means that this angle right here has to be 32. And the same goes for these 2 top angles over here, 32 and 32. So that makes angle 2 equal to 32 degrees. Okay, now to find angle 1, what I'm going to do is I'm going to use the property of triangles where the angles add up to 180 degrees, and I'm going to use that triangle right there. And the reason why I picked that triangle is because angle 1's in that triangle, and I know that angle is 90 and that angle is 32. So if I take 90 and I add it to 32, that's 122, and then to find angle 1, I would just go 180 minus 122. So that's 58 degrees. So there we go with number 17. Number 18. All right, so the first thing we want to do is we want to figure out what kind of special parallelogram is this. Well, notice we have 90 degrees here, but all the sides are not marked as equal. So this is a rectangle. So number 18 is a rectangle. Okay, so then I'm going to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. Okay, now once again, do not just say that 2 and 3 are 45 degrees. Okay, so, and the reason is, as we talked about in number 16, just because it's a rectangle means that all those angles are 90, but that does not mean it bisects this angle into two 45s. Okay, so don't do that with a rectangle. All right, so how are we going to find this? Well, if you notice, like we talked about in number 16, in a rectangle, all four pieces of the diagonals are equal to each other, which turns this angle right here, or this triangle, excuse me, right here that I'm highlighting in yellow, that triangle right there, that is an isosceles triangle, which once again means that the base angles, and the base is the side that's not equal in an isosceles triangle, so that's a base angle and that's a base angle, those are equal. So to find angle 3, what we would do is we would take 180, we would take away 56 from it, so that gives me 124, and then we would divide it by 2. That's how much angle 3 is. So that would be 62 degrees for angle 3. Okay, hopefully that makes sense. So that is 62. Then how do we find angle 2? Now remember, angle 2 and angle 3 make up 90. So to find angle 2, you would just subtract the 62 from 90, and that would give me 28. So angle 2 is going to be 28 degrees. Okay, then how do we find angle 1? Well, if you notice, angle 1 is right here. It's this angle. And it's right next to the 56 degrees angle, which is this angle right here. So these two angles are next to each other. They're adjacent, and they're on a straight line. So that means they're supplementary. So to find angle 1, you would just take away the 56 from 180, and that would be 124 degrees. So that's how you would do number 18. Number 19 and 20, the instructions say, find the measure of the numbered angles in the isosceles trapezoid. So we're dealing with isosceles trapezoids. Okay, so why is that important? Well, remember, if we have an isosceles trapezoid, it means the base angles are equal to each other. So angle 3 and that 45 degree angles would be equal, and then by the same reason it means that angle 1 would be the same as angle 2. Okay, so right away, if we want to find the measure of the numbered angles, we know that angle 3 is equal to 45 degrees. Okay, so that was easy. We didn't have to do any math to figure that one out. And we know that angle 1 and angle 2 are the same measurement. All right, so now how do we find either angle 1 or angle 2? So we use the fact that this is a trapezoid. So in a trapezoid, remember, the top base angle and its consecutive bottom base angle, so in other words, those two angles, or those two angles, they have to add up to 180. So that means that angle 1 plus this 45 degree angle have to be supplementary. They add up to 180. So when I subtract 45 from 180, we would get angle 1 is equal to 135 degrees. Okay, and that would be the same as angle 2 because the base angles are the same. Number 20, we're going to do the same concept, but whoever wrote this problem tried to trick you, and they flipped the trapezoid around. Okay, no big deal. So remember, the base angles are the same. So that means angle 1 is going to be the same as this 80 degree angle there, and that means that angle 2 is going to be the same as whatever angle 3 is. Okay, so right away, if I want to find the numbered angles, I know right away that angle 1 is equal to 80 degrees. Didn't have to do any math for that. I just had to know the rule about an isosceles trapezoid. And then angle 2 and angle 3 are going to have the same measurements. Okay, and the way that you would find it is, so remember, a bottom base angle, when you put it together with a top base angle, so in other words, if you put these two angles together, or if you put these two angles together, they have to be supplementary. Well, if that angle's 80, that means angle 3 has to be 100, because 100 and 80 make 180, which means angle 2 also has to be 100. All right, number 21, the next problem that was assigned to you. Actually, you didn't even have to do number 20. That's a bonus question right there. Okay, so I won't charge you for that, for doing number 20. Sorry about that. 21. All right, so we're going to find the value of x in the trapezoid, and then we're going to find the 3 line segments, okay? So if you notice in number 21, we have this line segment right here, right in the middle, so that's called a mid-segment. And then we have values for the 2 bases. So we have 27 is the value of that bottom base, and 4x plus 1 is the value that represents the top base. So what we're going to do is we're going to use the concept of a mid-segment. So remember, the mid-segment rule says this, that whatever the mid-segment is, which in this case is 5x plus 2, is equal to the 2 bases added up, 4x plus 1 added up with 27. We call that the sum of the 2 bases divided by 2. So the mid-segment is equal to the sum of the 2 bases divided by 2. Okay? So when you solve this problem, first of all, you want to simplify the numerator. So when we simplify the numerator, we would get 4x plus 28, positive 1 plus 27 is positive 28, divided by 2. Okay, now if 2 divides into both of the values in the numerator, 4x and 28, go ahead and divide it out. It'll ultimately make it easier for you to solve. So you could see that when I divide 4x by 2, that becomes 2x. When I divide positive 28 by 2, that becomes positive 14. So I get 5x plus 2 is equal to 2x plus 14. And now I'm going to solve. Subtract 2 x's from both sides of the equation. That would cancel out the 2 x's. My new equation is 3x plus 2 is equal to 14. Subtract 2 from both sides of the equation. The 2's would cancel out. 3x would be equal to 12. Divide both sides by 3. Therefore, x is going to be equal to 4. Okay, so let's see, did we answer what the problem said? The direction said find the value of x. I did that. Check. In the trapezoid in all 3 line segments. So I need to plug or substitute 4 back in. Okay, so that means side KL would become 4 times x, but we're going to put 4 in the place of x, so 4 times 4 plus 1, that's 17. Okay, side or line segment HI is going to be equal to 5 times x, but x is 4 plus 2, so that makes that 22. And then we don't have to find segment NM because it's already 27. Okay, moving on to number 22, we're going to do the same concept as number 21. So we have a mid-segment here, which is represented by 16. And then we have 2 bases, the bottom base represented by 2x minus 5, the top base represented by 2x plus 9. Okay, so we're going to use the mid-segment rule again. So once again, the rule is you take the mid-segment, which is 16, it's going to be equal to the 2 bases added up. So the sum of the 2 bases, 2x plus 9, added with 2x minus 5, but then we're going to divide the 2 bases added up by 2. Okay, so there's your equation that you would create in order to solve the value of x. Okay, so now when we solve this, let's simplify the numerator first. So 16 is equal to 2x and 2x make 4x. Positive 9 minus 5 make positive 4. Then we're going to divide by 2. Okay, now since 2 divides into both parts of the numerator, go ahead and divide it out. So 4x divided by 2 is 2x, plus 4 divided by 2 is 2. So now my equation becomes 16 equals 2x plus 2. And now I'm going to use simple algebra to solve this equation. 14 is equal to 2x. Divide both sides by 2. So we get 7 is equal to x. Okay? So that would be your answer. Now that's not all of our answer, because now we need to find how long the 3 line segments are. Well, we know that one's 16, but now we got to find this one. So we're going to take 7 and we're going to substitute it for x. So this top base would become 2 times 7, which is 14. 14 plus 9 is 23. So there's how long the top base is. The bottom base would become 2 times 7, which is 14. 14 minus 5 is 9. Okay, so there we go. That would be number 22. Okay, then we skip 23 and 24, and we go to number 25. And when you did number 25, I did not want you to find the midpoint of either of the segments there. I just wanted you to tell me what were the coordinates of Q and what were the coordinates of S. Well, S is easy. S is right here at the origin, so the coordinates of the origin are always 0, 0. So there's your coordinates for S. Now Q, we have to do a little bit of thinking, okay? So notice Q is going to have coordinates. So the first value I put in is my X value. It's how far I go to here on the x-axis. Now if you notice, Q is perfectly lined up with R, and that C value tells me. So that means that value is C. Then the second value is how high you went up. And if you notice, Q has the same height as P, and P has a height of K. So that means the coordinates for Q would be CK. There we go. CK. Okay. Number 26. 26 says 3 of the vertices of a parallelogram are 1, 4. I'm going to call that A, and I'm going to plot it over 1, up 4. There's A. Okay, 3, 1 over 1, 2, 3, up 1. I'm going to call that B. You could have called it whatever you wanted to. Over 6, up 3. So 3, 4, 5, 6, up 3. I'm going to call that C. And then it says find the coordinates of the fourth point. I'm going to call the fourth point D when I'm done graphing this. And then justify mathematically how you found your point and place your parallelogram on the graph. Okay? So I have to find a value for D right now. Okay, and when I'm done, wherever I put D, when I connect A to B to C to D, and not necessarily that order, in any order that I want, I'm going to get a parallelogram. Okay, so here's one way that I do it. If you notice that to get from A to C, I have to go down 1 over 1, 2, 3, 4, 5. So that means to get from wherever the next point is to B, I have to do the opposite of that. So I would have to go up 1 over 1, 2, 3, 4, 5. And that's how I do it. Okay, so that's where D could be. -2, +2. So that could be an answer for number 26. Okay, and by the way, that's not the only answer. And when I'm done with this problem, I'll give you the other possibility you could have said in order where you could have put A, B, C, and D. But if you notice, when I connect these, my shape is supposed to be a parallelogram, and this shape looks pretty darn close to a parallelogram. Okay, so there we go. Now, how do I justify mathematically that this shape is a parallelogram? So remember, what I'm going to do is I'm going to find the slope. Okay? I'm going to find the slope of all sides. All right? And when I find the slope of all sides, I'm going to compare the opposite sides to each other. So in other words, I'm going to find the slope of D to B first. Okay? So remember, when I find slope, I'm going to use the concept of rise over run. So if I want to find the slope from D to B, I'm going to start at the lowest point, which is B. And I'm going to rise up, straight up, until I get even with D, and that's one space. And then I'm going to run over until I get to D, and you notice I run over 5 spaces. So my rise is 1, and my run is -5. So my slope from D to B is 1 over -5. Okay, so that's what we just found. Now I'm going to find the opposite side of DB, which is AC. So next I'm going to find the slope of A to C, or C to A. And in this case you want to find it from C to A, because C is the lower point than A. So I'm going to rise up 1. I'm going to run over 1, 2, 3, 4, 5. And I ran to the left, so my slope is 1 over -5. Notice both of these sides have the same slope. So what does that tell you? If they have the same slope, it tells you they're parallel. So I just mathematically showed that side D to B is parallel to side A to C, okay? Now I'm not done, because that just shows me one pair of parallel sides. I need to have 2 parallel sides. So that means the next thing I need to do is I need to find the slope from D to A, and I need to find the slope of side B to C. Okay, so let's find the slopes of those. So D to A. Start at the lower point, D. Rise straight up, 2. Run over, 1, 2, 3. So D to A's slope is 2 over 3. Okay, and then we're going to do the same to get from B to C. And I'm going to start at B because it's the lower point. So I'm going to rise up 2. I'm going to run over 1, 2, 3. So the slope of B to C is also 2 over 3. They have the same slope. Therefore, D to A is parallel to B to C. Okay, so now we have 2 pairs of parallel sides. I have now mathematically shown that this shape has to be a parallelogram. Okay, number 27. We're going to determine whether each statement is always, sometimes, or never true. Okay, and what we're doing is we are using the chart that you put together on October 18th. So you're using this chart right here, okay, where we had this chart. All right, and remember, if you don't have this in your notes, you need to add this in if you don't have it. So remember, we use this chart to determine always, sometimes, or never. So we could either read the chart going up, or we could read the chart going down, or we could read the chart going across, left to right or right to left. Okay, and if you read the chart going left to right, the answer will be never. It's never true. If you read the chart going up, the answer is always. Okay, always. If you read the chart going down, the answer is sometimes. So that's how we read this chart, okay? So we're going to be referring to this chart here. So if you notice in number 27, it says a rectangle. And you know what? Let me see if I could zoom this out enough so we can see both the chart and the question at the same time. Let's see if I can do this here. Hold on. Sorry, I'm taking my worksheet and I'm tearing it apart. I'm going to fold it. So let's see if this works. Boom, look at that. Oh, wait, don't look at that. Now look at that. Good job. Okay, so here we go. So the first 3 questions are very easy because I need to, if you notice, there's 2 shapes mentioned. So a rectangle is a square. The first shape is a rectangle. The second shape mentioned is a square. That means we go to the chart, start at rectangle, move to a square. We're moving down the chart. When you move down the chart, the answer is sometimes. So this first one was sometimes. Second one, a square is a rhombus. So square is mentioned first. Rhombus is mentioned second. That means we're starting at square. We're moving to rhombus. Okay, we're moving up the chart. When you move up the chart, the answer is always. Okay, the third one, a rhombus is a rectangle. So the first shape mentioned is rhombus, which is right there. The second shape mentioned is rectangle. So we're moving this way. We're moving across this chart. So the answer is never. A rhombus is a rectangle. That is never true. Okay, a square is a rhombus. That is always true. Okay, now when we get to the next couple problems, there's only one shape mentioned. So if you notice in this one, it says the diagonals of a parallelogram are perpendicular. So the only shape mentioned is parallelogram. Okay, so here's how you're going to answer these. What you're going to do is you're going to still use the chart, but you're going to start at parallelogram. And then you're going to answer yes or no, are the diagonals of each one of these 4 shapes, including parallelogram, perpendicular? Okay, and you have to know the properties. And if you don't know the properties, well, you have notes where you could look them up. Okay, so parallelogram, are the diagonals perpendicular? That answer is no. Rectangle, are the diagonals perpendicular? That answer is no. Rhombus, are the diagonals perpendicular? That answer is yes. And how about a square? Well, a square is, if any one of these answers are yes, a square is automatically yes. So notice we have 2 no's and 2 yeses. So if you end up with some no's and some yeses, they don't have to be equal, but some of one and some of the other, the answer is sometimes. Okay? The next one, the diagonals of a parallelogram are congruent. Okay, so that means, notice the only shape mentioned is a parallelogram. So that means I'm going to start at my chart at parallelogram, and then I'm going to answer yes or no for each one of the shapes, the 4 shapes, including parallelogram, are the diagonals congruent? Okay, are the diagonals in a parallelogram congruent? That answer is no. How about in a rectangle? Are the diagonals congruent? That answer is yes. How about in a rhombus? Are the diagonals congruent? That answer is no. And then remember, a square is, if any one of the ones above it is yes, the answer is yes. So the diagonals are congruent in a square. Now once again, I have some yeses and some nos, so my answer is sometimes. Okay, hopefully that makes sense. Last one, number 28. Or number 30, excuse me. Last one, number 30, here it is. So in number 30, WXYZ is a rhombus, so this shape is a rhombus. Okay, we're going to find the following, and then we're going to state the rule or property used to solve. Okay, so we know it's a rhombus. Now that's super helpful. So you have to remember, what do you notice? What do you know about a rhombus? So remember, the first thing is, in a rhombus, the 4 diagonals in the middle are all, the 4 angles in the middle are all 90 degrees. So that means that C is equal to 90 degrees. Okay, and what's the rule that I use? The rule that I use is that the diagonals, when a shape is a rhombus, the diagonals are perpendicular. Okay, and that's the symbol for perpendicular right there, upside down capital T. What does perpendicular mean? It means that where the 2 diagonals intersect, you get 90 degrees. Okay, then we're going to go down here, and we're going to use the fact that this angle is 62 to find the angle B. So remember, in a rhombus, if that angle is 62, it means all of these angles are 62. That has to be 62, and both of those angles up there as well have to be 62 degrees. So that means B is equal to 62 degrees. And what's the property that we use? So we use that when a shape is a rhombus, the diagonals bisect each opposite angle. Each opposite angle. Okay? Bisect means we have 2 equal angles, 62 and 62 and 62, and these angles are opposite of each other. Okay? And then now we're going to find A. And in order to find A, what we're going to do is we're going to focus on the triangle that's inside the rhombus that A is part of. So in other words, we're going to focus on this triangle right here. Okay, and then what we're going to do is we're going to use the fact that the 3 angles inside a triangle add up to 180. So to find A, we're going to go 180, and then we're going to take away whatever 62 plus 90 is. Okay, 60 plus 62 plus 90. I said that right. So 62 plus 90 is 152. So this would become 180 minus 152. So A would be equal to 28 degrees. Okay, now what property or rule did we use there? We used that the sum of the angles, the interior angles to be exact, sum of the interior angles in a triangle is 180 degrees. Okay, last one. Now we're going to find the rule or property. We're going to find out how long it is from Y to Z. Okay, and Y to Z is right here. So that's that one right there. Now you may be thinking, Mr. Trutna, that's crazy talk. How could you do that? Well, remember, this shape is a rhombus. So that means that all the sides are exactly the same. Okay, so that means I could find the value of n, and I could then plug in the value of n to figure out how long each side is. So how am I going to find the value of n? I'm going to use the fact that side WX, which is represented by 9n minus 7, is equal to side XY, which is represented by, that's y, 4n plus 23. So I'm going to use the equation 9n plus 27 is equal to 4n plus 23 to find the value of n. Okay, so I'm going to subtract 4n from both sides of the equation. I'm going to do the Texas 2-step here. I'm going to do 2 steps in one. I'm going to add 7 to both sides of the equation. Those 7's will cancel out. The 4n's will cancel out. My new equation would be 5n is equal to 30. I would divide both sides by 5. N is equal to 6. Okay, well that's not the answer I'm looking for. I'm looking for how long it is from y to z. Well, y to z is the same as x to y. So how do I find x to y? Well, I just substitute 6 in the place of n. So x to y becomes 4 times 6, which is 24. 24 plus 23 is 47. Okay, so that means x to y is 47. That means y to z is 47. Okay, so that would be it. Now what property did I use? I used that if a shape is a rhombus, all sides are congruent. Okay, there you go. Good luck on your test. Coming up, your teacher is about to give you your Scantron and your test, okay? You may use a calculator for it, and then your teacher is going to explain to you what problems he or she wants you not to do, and then you're going to make a little bit of changes on the test as well. Okay? See you guys on Friday.